You have $2,400 and a graphics card somebody else already used for 2 years. That's the whole empire, day one. It's sitting on your desk in an anti-static bag, still warm from the shipping truck, and it has a small scratch on the backplate that the seller swore was cosmetic. You are about to plug it into a wall outlet in a rented apartment and start a company that, 6 levels from now, will be talked about in gigawatts. Here's what nobody tells you about that climb. Every level of this business has one move that works. One trick, one edge, one thing that makes the money show up. And at every single level, the exact move that got you there is the thing that breaks you at the next one. The scrappiness that makes you money in a closet gets you evicted from a colocation cage. The financing that builds your first real facility is the financing that can vaporize you at 100 megawatts. The whole ladder is built like that, rung by rung, each one filed down by the one below it. So we're going to climb it properly. 6 levels. One used GPU to a 1,200-acre campus in West Texas. Real numbers, real 2026 prices, real constraints, the ones that don't care how good your pitch deck is. And somewhere around level 4, you're going to notice something strange. You'll notice that you've stopped talking about chips. You'll notice that your calendar is full of people who have never written a line of code in their lives, electrical engineers, county commissioners, a guy whose entire job is transformer procurement. You'll notice your competitors aren't other AI companies. They're utilities, because the punchline of this entire industry, the thing you can only see from the top of the ladder, is that nobody up there is really selling compute. They're selling something else and charging for it by the GPU hour. But you don't know that yet. Right now it's a Tuesday, you're kneeling on carpet with a screwdriver in your mouth, and you're about to learn the first law of this business the way everyone learns it. By tripping a breaker. Level 1 is a closet, not a metaphor. An actual closet, the one in the second bedroom, with the door taken off the hinges and a box fan wedged where your winter coats used to be. The card goes into a tower you built from parts, the tower goes on a wire shelf, and the whole thing draws power from an outlet that was installed in 1998 for a lamp. You are so far below the real hardware, it's almost funny. The chips everybody writes headlines about, an H100, the workhorse of the last build-out, run $30,000 to $40,000 a piece brand new, and that's for one accelerator, before the server around it. You're not in that world. You're in the used market, the last generation market, the market where somebody upgraded and wanted the cash. But the strange thing is, it works. You list the machine on a marketplace and someone rents it. A grad student in another time zone, probably, fine-tuning something at 3 in the morning. The dashboard ticks over in dollars per hour and you refresh it more than you'd like to admit. $2, then 4, then 9. It is the most passive money you have ever made, and it arrives while you are asleep, and it feels genuinely like you found a crack in the world. So you buy another card, then a third, and then you trip the breaker. Because a standard 15-amp household circuit gives you about 1,800 watts, and that is a hard ceiling written into your wall by an electrician who died before you were born. 3 cards under full load, plus the machines around them, plus that box fan, plus the fridge on the same run in the kitchen, and the lights go out at 2 a.m. in the middle of a paid job. You reset it. It happens again. You start running extension cords to other rooms like a hostage negotiator, mapping which outlet belongs to which breaker, and the room sits at 91 degrees with the window open in February. That's the first law, and it never stops being true, not at any level of this thing. Compute is easy to buy. Anyone with a credit card can buy compute. Power and heat are the entire business, which is why level 2 is a cage. You find a colocation facility 40 minutes outside the city, a low windowless building next to a substation, badge readers on every door, air so cold and dry your knuckles crack. And you stop being a guy with hardware in a closet. You become a tenant. A full rack here runs somewhere between $900 and $2,000 a month depending on the market, the tier, and how much power you want behind it. That's the retail end. Once you're taking real space, a couple hundred kilowatts, wholesale, asking prices in the primary North American markets sit around $196 per kilowatt per month, and by the time you add the cross connects, the remote hands, and the network, you're closer to $250 all in. Read that pricing again, because it's the whole lesson of level 2. Nobody is charging you for square feet, they're charging you for kilowatts. The floor is free, the cabinet is nearly free. What you're actually buying is the right to pull a specific amount of electricity through a specific piece of copper, 24 hours a day, and everything else in the contract is decoration around that number. You take 5 kilowatts, 6 months later you take 50. There's a guy named Marcus who runs the loading dock and has watched 100 companies do exactly this. And he starts nodding at you differently, not friendlier. Exactly, just a nod you give someone whose story you already know the ending of. You also start learning that geography is a price. The same cabinet, the same power draw, costs wildly different amounts depending on which dot on the map it sits on. Atlanta stays one of the cheaper major markets. Singapore will quote you somewhere between $330 and $475 per kilowatt per month because there is an island's worth of demand and a finite amount of grid to serve it. You begin choosing cities the way a manufacturer chooses them, by input cost, not by where you'd like to live. And in almost every primary market now, power availability has overtaken floor space as the binding constraint. There is empty room in these buildings. There is not empty power. Salespeople who spent their careers selling square footage now spend it apologizing about megawatts. Then you try to go dense, because the hardware has moved. The rack everybody wants now, NVIDIA's GB200 NVL72, 72 GPUs bolted into one liquid-cooled rack-scale system, draws about 120 kilowatts, and deployed units have been reported pulling 130 under full load. One rack, 130 kilowatts. The building you're standing in was designed for 5 to 8 kilowatts a rack. You are asking a facility built for the last decade of computing to feed a single cabinet more power than it planned to give an entire row, and to take the heat back out with liquid instead of air. The answer isn't no. The answer is worse than no. It's a quote for a retrofit that costs more than your company on a timeline measured in quarters, from a landlord who has 6 other tenants asking the same question and will serve whoever signs biggest. That's law number 2. You never rented space, you rented amperage. And your landlord runs out of it long before you run out of ambition. So at level 3 you stop renting hardware and start owning it. This is where you become what the industry calls a Neocloud, not a hyperscaler, not a landlord, just a company that buys enormous quantities of silicon and sells access to it by the hour. And this is where the money gets strange, because you cannot buy this hardware out of cash flow. Nobody can. A single GB200 NVL72 rack costs roughly $3 million. And you don't need one, you need dozens. So you do what everybody at this level does. You go get a customer to sign a contract, and you take that contract to a lender. And the lender gives you money against it, and you use the money to buy chips that you then pledge as collateral. You are borrowing against a promise to buy a thing that depreciates. Say that out loud a few times because it's the entire risk profile of level 3 in one sentence. Now the math. An H100 bought around $30,000, run at going marketplace rates, throws off somewhere in the range of $600 to $800 a month in gross revenue before you pay for power, space, staff, or the loan. Hardware break-even lands somewhere around 35 to 44 months under current conditions. 3 to 4 years to get your money back on the chip. And the debate that has been tearing through this industry's earnings calls is exactly that. Hyperscalers and Neoclouds depreciating GPUs over 6 years, analysts publicly calling that fantasy, arguing the useful economic life is shorter, that a card sheds 15 to 20% of its value for every year the next generation stays in production. If they're right, you're paying for a 5-year loan with a 3-year asset. The resale market gives you a partial answer, and it's a split decision. Through roughly the first 24 months, an H100 holds something like 75 to 85% of what you paid for it, which is remarkable for a piece of consumer-adjacent electronics and is exactly the number the 6-year camp points at. But the curve after that is a cliff, not a slope, and it steepens every time the next generation gets easier to buy. You are not holding a building, you are holding something closer to a very expensive car that a competitor is allowed to replace with a better one annually, forever. And your customer base is not what a lender would call diversified. 2 or 3 names carry most of your revenue, because those are the only names writing checks big enough to justify racks at this price, which means your entire credit story rests on a handful of counterparties whose own funding is, in many cases, no more permanent than yours. And the rental price you're modeling all of this against is not a fixed thing. 1-year H100 contract pricing bottomed near $1.70 an hour in October of 2025, then ran up almost 40% to about $2.35 by March of 2026. That's a good swing. It's the swing that makes people rich. But it swings both ways, and your loan payment does not swing at all. There is a version of you at level 3 that is spectacularly profitable. Utilization at 90+%, contracts stacked back to back, every rack earning while the debt amortizes. It feels like genius. It is genius right up until a customer doesn't renew and you have $3 million of liquid-cooled hardware sitting idle in a room that still costs you rent and power to keep cold. That's the third law, and it's the one that ends most people. Leverage against a depreciating asset works beautifully as long as utilization never blinks. Not never drops, never blinks. The only way out of that trap is to own the room. So level 4 is a building. You buy a shell, usually not a pristine greenfield, usually something dead. A distribution warehouse, a shuttered fab, a printing plant whose company stopped existing in 2011. What you're really buying is the concrete slab, the ceiling height, and the utility feed that came with the previous tenant's ambitions. And you become the landlord you spent all of level 2 complaining about. The numbers change character here. Conventional hyperscale construction in 2026 runs roughly $10 to $12 million per megawatt of capacity. But you're not building conventional. You're building for the racks that broke your last facility, which means liquid cooling loops, high voltage distribution, structural reinforcement for equipment that weighs like a small vehicle, and AI-optimized builds run 15 to 20 million per megawatt. So a modest 30 megawatt facility, the kind that sounds almost quaint next to the headlines, is a $400 to $600 million project. Before you buy a single chip, scale that up and the split becomes clearer. A 100 megawatt facility runs somewhere around 1.1 billion for the shell and core, the building essentially, and 1.6 to 2.2 billion once it's fully fitted out with electrical distribution, cooling, and fire suppression. The difference between those two numbers is the actual business. Anyone can pour a slab. Getting $2 billion of mechanical and electrical systems to work in unison, on schedule, is the thing almost nobody can do. And now you meet the overhead you've been paying invisibly your entire career. Every watt you deliver to a GPU requires additional watts to move the heat back out. Pumps, chillers, air handlers, fans. The ratio has a name, PUE, and it is the difference between a facility that prints money and one that quietly bleeds. The best operators live near 1.1, meaning they burn about 10 cents of cooling for every dollar of compute. An older, badly run building might be at 1.5, and that facility is structurally uncompetitive against yours forever, not for one bad quarter permanently, because it pays a 50% tax on physics. A tenth of a point of efficiency across 30 megawatts is a line item with a comma in it every single month for the life of the building. Which is why you will find yourself a person who got into this because of software in a genuinely heated argument about water. How much you use, where it comes from, what the county thinks about that. Whether you go to a closed loop and eat the efficiency hit to avoid a headline. Then you learn about lead times. You need large power transformers. Everyone needs large power transformers. They are enormous, they are custom, they are built by a small number of manufacturers on a planet where every hyperscaler, every utility, and every developer like you is standing in the same line, and lead times run 2 to 4 years from most suppliers. 2 to 4 years. For a metal box, this is the moment the job changes underneath you. Your critical path is no longer engineering talent or model performance or anything a technology company would recognize. It's a purchase order placed 30 months ago by somebody with better foresight than you. Your calendar fills with people who have never touched a terminal, a substation engineer, a county planning board, a mechanical contractor who wants to know your redundancy tier before he'll quote. Somewhere in there you catch yourself explaining chilled water set points to an investor and realize you haven't thought about a model in 4 months. Fourth law. At level 4, you are an electrical contractor and a real estate developer wearing a technology company as a costume. The compute is just how you bill. And then you try to build the next one at 100 megawatts, and you discover that money has stopped being the constraint. Level 5 is where the empire runs into physics and paperwork at the same time, and paperwork wins. You have the capital, you have the customer demand. You have a site, a design, a contractor who can pour by spring. What you do not have is permission to draw 100 megawatts out of the grid, and that permission is not a thing you can buy at any price. You have to queue for it. As of early 2026, the United States interconnection queues held something like 2,600 gigawatts of proposed generation and storage, a backlog roughly twice the entire operating capacity of the country's existing grid. Waits of 5 years or more are normal. Inside the PJM footprint, the territory that covers a huge share of the East Coast's data center gravity, the wait for a large new interconnection has run to roughly 7 years. Northern Virginia, Dublin, Singapore, Amsterdam, the world's densest data center markets, are quoting 4 to 7 years for new high-capacity connections. 7 years. Your chips depreciate in 3. So you do what the entire industry has done. You stop asking the grid for permission and generate your own. Behind-the-meter gas turbines can be standing and firing in 12 to 18 months versus years for a grid upgrade and forever for anything nuclear. That speed is why the planned natural gas pipeline aimed at this build-out swelled towards 64 gigawatts by 2030, with 16 gigawatts added to the queue in the first quarter of 2026 alone. You are now functionally a power producer that has a data center attached as a customer. You have an operations team that monitors turbine health. You have fuel exposure. You have a hedging strategy. None of this was in the business plan, and all of it is now load-bearing. You also acquire a new category of opponent, the ratepayer. Because the second your project shows up in a county's filings, somebody does the arithmetic on what 100 megawatts of round-the-clock load does to local generation, and the meetings stop being about jobs and start being about whose electricity bill moves. You will sit in a fluorescent lit room on a Tuesday night explaining your cooling design to 70 people who did not ask for you to exist, and how that meeting goes determines a 9-figure schedule. Meanwhile, your acquisition strategy inverts completely. You stop looking for good sites. You start looking for good interconnects, a decommissioned coal plant with its transmission rights intact, a mothballed aluminum smelter with a substation nobody's using, a stranded gas field with nowhere to send the molecules. The dirt is irrelevant. You'd take a swamp with a switchyard over a perfect parcel without one, and you'd pay a premium to do it. Land, at this level, is just packaging around a power right. And you're late. Everyone at this level is late. The best interconnect positions in the country were filed for by people who had no idea what they'd eventually host, crypto miners, industrial developers, speculators, who simply understood that a queue slot is an option on the future and options are cheapest before anyone wants them. Those people are now your landlords or your acquisition targets or your competitors, and they did nothing smarter than get in line early. Fifth law, and it's the one that separates the people who built empires from the people who wrote very good business plans. The moat was never the chips. The chips are a purchase order. Anyone with financing gets the same ones you do. The moat is your position in a queue you joined years before you knew what you needed for. Which brings you to level 6 and to a piece of West Texas that looks from the highway like absolutely nothing. Abilene, roughly 11 to 1,200 acres of flat scrubland, wind and construction cranes. Built out by Crusoe on ground originally assembled by a company that had been quietly accumulating power capacity in that corner of the state for years, with Oracle operating the compute inside it for OpenAI. Planned to deliver up to 1.2 gigawatts. The campus has been estimated at around $15 billion, and Crusoe secured roughly $11.6 billion in financing to build it, which, at the time, made it the most expensive data center project ever financed. You crossed $10 billion here. Level 6. Congratulations. And notice that it does not arrive all at once because nothing at this scale does. A campus like that comes online in phases. The first 133 megawatts of it was handed over to CoreWeave in April of 2026, while cranes were still working on everything behind it. That's the shape of the whole industry compressed into one site, one phase earning revenue, 3 phases under construction, and a financing structure that assumes all of them eventually fill. Now look at where the money actually goes, because it is not where anyone assumes. The concrete, the steel, the switchgear, the cooling, the substations, the roads, the land itself, all of it, the entire physical plant that takes years and armies of contractors to assemble, runs on the order of $3 to $4 billion per gigawatt. That's the part you can photograph. That's the part with the drone footage. Everything above that number is silicon. The building is the cheap half. You spend $3 or $4 billion on a gigawatt of shell and power, and then you fill it with racks at $3 million each, and the hardware bill dwarfs the thing containing it. For the very largest full-stack projects, all-in figures have been put at $45 to $55 billion per gigawatt. The concrete is a rounding error against the chips it holds. And almost none of it is your money. At this level you are not investing, you are structuring. A special purpose vehicle that owns exactly one campus and nothing else. Project debt against a signed offtake agreement from a counterparty with a credible name. Equity slivers, vendor financing from the people selling you the chips, which means the company booking the revenue from the hardware is also, indirectly, helping fund its own purchase. The building is collateral, the contract is the credit story, and your actual job, the thing you personally do all day, is keeping a very long chain of promises from anyone breaking. It is an elegant machine. It is also a chain, and chains have a property that portfolios do not. Every link has to hold. The lender is fine as long as the offtake holds. The offtake holds as long as the customer's own funding holds. The customer's funding holds as long as the market believes the demand forecast. And the demand forecast is the one link in that chain that isn't made of anything. In March of 2026, Bloomberg reported that the plan to expand that same Abilene campus from 1.2 gigawatts toward 2 gigawatts had been abandoned, negotiations collapsing over financing terms, and what was described as often changing demand forecasting from the customer. Not a technology failure, not a power failure. The concrete was fine. The chips were available. The forecast moved. That's the sixth law, and it's the last one, and it's the one that reframes everything under it. At this scale, you are not selling compute. You are underwriting somebody else's belief about how much compute they will need in 2031, with billions of dollars of other people's money, against assets you cannot repurpose, on a timeline nobody in this industry has ever successfully predicted. So climb back down for a second and look at what the ladder actually was. Level 1, you learned that power is the constraint, not chips, and that knowledge is exactly what pushed you into a colocation contract at Level 2. Level 2 taught you that you were buying amperage, not floor space, and that lesson is what made you go dense enough to get quoted out of the building. Level 3's leverage bought you scale and handed you a payment schedule that outlives the hardware. Level 4's building freed you from a landlord and turned you into one, with a 2 to 4 year transformer sitting on your critical path. Level 5's Q position became your only real moat, and Level 6 turned that moat into a multi-billion-dollar bet on a number in someone else's spreadsheet. Every rung filed down by the one below it, just like promised. And here's the thing you can only see standing at the top, the thing that would have sounded insane back when you were kneeling on carpet with a screwdriver in your mouth. You never built a compute company. You built a power company, a real estate portfolio, and a structured finance desk. Compute was just the unit you build in, the meter on the side of the building. The businesses that won this build-out weren't the ones with the best chips, because everybody buys the same chips from the same vendor at roughly the same price. They were the ones holding land with transmission rights, queue positions filed in 2019, and turbine orders placed before anyone else knew they'd need one. And there are exactly two clocks that end empires at this altitude. The first is depreciation, silicon quietly losing 15 to 20% of its value a year while the loan against it does not. The second is somebody else's demand curve, which is not a physical quantity and can be revised in a single meeting you're not invited to. Concrete lasts 30 years. Transformers last 40. Interconnection rights are close to permanent. The chips are the part that melts. Which means the smallest version of this ladder is the same as the largest. If you're renting a GPU by the hour tonight, you're paying for someone's power contract, someone's transformer order, and someone's queue position from 7 years ago. That's the product. That's what the invoice is actually for. The compute is just how they charge you for it.